Overview: Earth's celestial companion. The Moon is Earth's only natural satellite, orbiting at an average distance of 384,400 kilometers, 238,855 miles. It's about 1/4 the size of Earth with a diameter of 3,474 kilometers. It's tidally locked, meaning we always see the same side from Earth. Orbit and phases. Orbital period approximately 27, 3 days, sidereal, but the lunar cycle, new moon to new moon, is approximately 29, 5 days, synodic. Phases: new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, caused by the moon's position relative to Earth and the sun. Surface and composition: rocky and cratered, shaped by billions of years of impacts. No liquid water but ice deposits exist in permanently shadowed craters. Extremely thin atmosphere called an exosphere, not breathable. Influence on Earth: drives tides through gravitational pull. Historically used to track time, many calendars are based on lunar cycles. Exploration highlights: Apollo missions 1969-1972. Humans walked on the moon and brought back 842 pounds, 382 kilograms of lunar rocks. Over 105 robotic missions have explored the moon. Future plans include NASA's Artemis program and ISRO's lunar missions. Fun and cultural facts, known as Luna in Latin, inspiring terms like lunar and lunatic, has inspired myths, poetry, and art for centuries. No dark side. Both sides get sunlight, but only one faces Earth due to tidal locking. All about the moon. Quick facts: Earth has just one moon, a rocky, cratered place, roughly 1/4 the size of Earth and an average of 238,855 miles away. The moon can be seen with the naked eye most nights as it traces its 27-day orbit around our planet. Chances are that when you imagine the night sky, one of the first things that comes to mind is the moon glowing in the darkness. The moon has always held a special place in our imaginations and in daily life. It's no wonder that we are fascinated. The moon is Earth's only natural satellite and one that we can easily see most nights. The moon has inspired wonder and creativity for thousands of years. This image appeared in a 1902 French film called Le Voyage dans la Lune, A Trip to the Moon. What makes the moon glow? The moon does not shine with its own light. It simply reflects light coming from the sun. This is the face of the moon that we see from Earth. This image is based on data from NASA's Lunar Reconnaissance Orbiter spacecraft. Why does it look like the moon is changing shape? From Earth it might look like the moon is changing shape each night, from a tiny sliver to a half moon to a full moon and back again. What's actually happening is that from our spot on Earth, we see different parts of the moon lit up by the sun as the moon travels in its orbit. Is there actually a dark side of the moon? No, the moon rotates on its own axis at the same rate that it orbits around Earth. That means we always see the same side of the moon from our position on Earth. The side we don't see gets just as much light, so a more accurate name for that part of the moon is the far side. How did the moon form? Scientists believe that the moon formed early in the solar system's history after Earth and an object about the size of Mars smashed into each other. The impact sent chunks of Earth and the impactor into space that were pulled together by gravity, creating the moon. How do we study the moon? Even thousands of years ago, humans drew pictures to track the changes of the moon. Later, people used their observations of the moon to create calendars. Today, we study the moon using telescopes and spacecraft. For example, NASA's Lunar Reconnaissance Orbiter has been circling the moon and sending back measurements since 2009. The moon is the only other planetary body that humans have visited. On July 20, 1969, NASA astronauts Neil Armstrong and Buzz Aldrin were the first people to set foot on the dusty surface of the moon. 10 other American astronauts followed. They collected hundreds of pounds of lunar soil and rock samples, conducted experiments, and installed equipment for follow-up measurements. What do we know about the moon? Today we know that the moon is covered by craters as well as dust and debris from comets, asteroids, and meteoroid impacts. We know that the moon's dark areas, called Maria, which is Latin for seas, are not actually seas. Instead, they are craters that lava seeped into billions of years ago. We know that the moon has almost no atmosphere and only about 1/6 of Earth's gravity. We even know that there is quite a bit of frozen water tucked away in craters near the moon's poles. There is no wind or air on the moon to help erase craters, so the surface is covered with the remains of old and new impacts. There are still many questions left to answer about the moon, and the most exciting days of lunar activity may still lie ahead as NASA sends humans on the next missions to the moon and eventually onto Mars. Everything you've ever wanted to know about the moon. The moon is Earth's most familiar companion, the closest astronomical object to the Earth. No other planet has a satellite as large in comparison to its own size. How was the moon formed? There are a few different ideas for how the moon came to be our nearest celestial neighbor. The most widely accepted theory by the scientific community is that the moon was formed by a giant impact with a rocky body we call Theia. When the sun first formed in our galaxy, leftover dust and gas was swept up in its orbit. The Earth and the other planets formed out of this cloud of material. The young solar system was an incredibly turbulent place with a lot of collisions between large, rocky bodies. The giant impact theory of the moon's formation suggests that a rocky body about the size of Mars smashed into the young Earth, which threw debris out into space. Gravity pulled the debris from the impact together as it orbited the Earth, which collected to form the moon. NASA's Apollo missions brought back over a third of a ton of rock and soil from the moon, allowing scientists to better understand how it formed. If the moon had previously been an asteroid and formed somewhere else in the solar system, the moon and the Earth would have different compositions. However, astronomers found that the composition of the moon and the Earth are similar, pointing to a linked history. How does the moon affect tides? The water on the side of the Earth closest to the moon is pulled by the moon's gravitational force. The effect is to make bulges in the water on opposite sides of the Earth. How big is the moon? The moon has a diameter of 3,476 kilometers. This means that you could fit about 4 moons across the diameter of the Earth. How much does the moon weigh? The mass of the moon is 7.35 x 10 circumflex 22 kilograms, which means the Earth is 81 times more massive than the moon. This would also mean that someone who can jump up to 5 feet on the Earth could jump 30 feet on the moon. How far away is the moon from Earth? The moon orbits the Earth at a mean distance of 384,000 kilometers. It takes the moon 27 days to orbit the Earth. How old is the moon? It is thought that the moon formed 4.51 billion years ago, not long after the Earth. Is there gravity on the moon? Although the Earth and moon are both very massive, the moon is smaller, so its force of gravity is less. Any object on the moon will weigh about 6 times less than it does on Earth. Any early atmosphere that the moon might have had has escaped from the moon's feeble gravitational pull. Because of the lack of any atmosphere, the temperature of the moon's surface varies between minus 180 degrees Celsius and plus 110 degrees C. The moon has little protection from the solar wind, cosmic rays or micrometeorites, and so it is not surprising that there is no form of life there. Why can we see the moon during the day? It is a common idea, particularly amongst children, that the stars and the moon are seen at night and the sun is seen during the day. In reality, however, the stars and the moon are always up there, although depending on your position on the Earth and the time of year, they won't all be above the horizon. During the day, the light from the sun, scattered by the atmosphere of the Earth, drowns out the much fainter stars. This makes them all but impossible to see without specialist equipment. However, the moon, being far closer and brighter than the distant stars, can often be seen during the day. The most likely time to notice it during the day is somewhere between a wide crescent and a thin gibbous, that is close to the quarter moon. At this point, the moon is illuminated enough to be visible, not at new moon, is far enough from the sun in the sky to avoid looking too close to the sun, as would happen at new moon or a thin crescent, but is not on the complete opposite side of the sky from the sun, and thus only rises when the sun is setting, as would happen around full moon. What are moon rocks? People have wondered about the composition of celestial objects for thousands of years, from Aristotle's idea of celestial ether and beyond. Determining an object's size, from its apparent size on the sky and its distance, and its mass, from the force of gravity it exerts, can give scientists an idea of what it might be made of. However, nothing beats having direct samples. Only a handful of celestial objects have been visited by automated probes. Even fewer have returned samples to Earth, and only one has been visited directly by humanity: our moon. Through the Apollo missions, around 380 kilograms of moon rock have been directly collected from the surface. We have also gathered a few hundred grams more from automated sample return missions. Finally, a number of meteorites that have landed on Earth have been positively identified as having originated from the moon. Observations from a distance and analysis of these samples have shown that the rocks of the moon share many similarities to those on Earth. This indicates that the moon likely formed from the same material that the Earth did. Perhaps the moon could even have directly come from the Earth itself through material released by an ancient impact. The lunar samples remain objects of study even today. Yet more discoveries are likely to be made as analysis methods change and improve and we learn more about our celestial neighbors. The lunar surface and the man in the moon. The moon's surface is characterized by light mountainous regions, interspersed with dark maria or seas. The man in the moon is formed from patches of these two types of terrain. The maria are vast impact basins which have been filled with basaltic rocks some 3,000 million years ago. Much of the moon's surface is covered with craters. These are the result of impacts by meteorites. The largest are about 200 kilometers in diameter, the smallest are only about a meter across. Most of these craters were formed between 3,000 and 4,000 million years ago. Americans have landed on the moon 6 times. The first time was in July 1969 and the last time was in December 1972. Much of our knowledge of the structure of the lunar surface and the geology of the moon comes from the landings of the Apollo series and the samples of lunar material brought back to Earth. Once in a blue moon. The phrase once in a blue moon is a familiar one, meaning once in a very long interval of time. A blue moon by folklore definition is said to be the second full moon of the month. However, researchers at Southwest Texas State University have been using historical documents to prove that a blue moon was really a term used by the Maine Farmer's Almanac to indicate the presence of a 13th full moon in a tropical year, which usually had 12. A tropical year is a measurement of time from one winter solstice to the next.